looks like this. 5x minus 2y minus 3x plus 7. Okay, so with your algebra tiles, I'm going to borrow this for a second, making sure that you're laying out your answers on your big large template over here. I want you to illustrate 5x minus 2y minus 3x plus 7. 5x.
This difference is x minus 300 over 6. And it's negative. Even without doing anything, we can say that we can say yes, but people take 2 steps.
I want you to, where's your algebra test? Oh, but just look at what they're doing, okay? Because sometimes on the test you have to illustrate with algebra tiles. So you need to, it doesn't matter, you still need to know what we expect on the test. So just look at what they're doing, okay? I'm going to turn around. Yeah. So 5x minus 2y. Okay, yeah, but now we have to figure out what does this mean with the positives, or how are we going to eliminate, okay? So the zero principle. Yeah, if you're trying to illustrate a negative number, just flip over the tile to the white part, okay? If you're having trouble, ask your partner next to you.
Keep in mind, it wasn't me to design it, but I would recommend you to pay special attention to this problem.
Okay, guys, so when we're talking about the zero principle, does anyone know what that means? We're talking about the zero principle. Do you know what that means? Matthew? Exactly. So if you didn't hear at the back, Matthew was saying positive 1 and a negative 1 cancel each other out. So if I have a positive 5x on the board, if I take a negative x and cancel out the positive x, positive 1 and negative 1 make 0. So that is the zero principle. We consider that a 0 now. I have another negative x and another negative x. Oops. Another negative x. So these three have essentially been canceled out. They no longer exist. So I know in my final answer, I'm going to have a positive 2x left over. Positive 2x. Now with our y's, how many y's do we have? And are they going to be negative or positive? Negative, good. So if I scroll down a little bit, I have one y over here and another y over here. We're going to make both of them negative values, negative y. So the negative 2y remains. So I've dealt with these three terms. How many unit tiles do you have on your big algebra board there? How many unit tiles did you put, Bianca? 7. And are they positive or negative? Okay. Do we have to combine anything with the positive 7? No. So to illustrate that, I need 1, 2, 3, 4, 5, 6,
and given
7.
that, the base is 4x.
Okay. And my final answer also has a positive 7. Now, what would happen if I added negative 4 to this question? What would I have to do with my algebra tiles to illustrate a negative 4? Rita? Exactly. Each negative value will cancel out one of my positive tiles. So 1, 2, 3, 4, and I will be left with positive 3. Oops. So instead of positive 7, it would be positive 3. Okay? So whenever you are using algebra tiles or on the test to illustrate a concept, remember to use colors. Make sure that the zero principle is clear, because I need to understand what you're doing in order to give you a mark for your test. Okay, let's deal with some different terms now. So with your partner, can you illustrate the following question?
What is the next step? What is our next step? You see that we are dealing with rational functions.
So this time we don't have any y terms. Matthew? Red one. So I have one negative x squared, another negative x squared, and another negative x squared. So negative 3x squared. So how many positive x terms did you start off with? How many positive, Bianca? 7. Okay, that's a lot. So 1, 2, 3, 4, 5, 6, 7. And how many of these positive x tiles did you cancel out with negative x tiles? Robin? 3? Okay. Negative 3x. That's correct.
So what it will be? This will be equal to x minus 7.
So these 3 are canceled out. In terms of unit tiles, do you have more positive or more negative unit tiles? Matthew? More negative. Okay, so we're going to start off with negative 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And how many of these negative tiles are canceled out with positive algebra tiles? How many, Ben? 5 of them? Good. So, 1, 2, 3, 4, 5. Okay, so the zero principle is applied to those. So I should be left with positive 4x, negative 4. Is that correct? Does everyone have that simplified expression? Okay, perfect. So that is a clear representation on how to use algebra tiles. Now we're going to move into multiplication, because I want to be able to illustrate the distributive property with you. So we're going to do this question. Remember, with multiplication, you're putting tiles on the side as well as on top. And our question that I want you to tackle is 3x times negative x plus 2. 3x times negative x plus 2. And we're going to be putting it on the side and on the top. So one expression is going to go on the side, one expression is going to go on the top. I'm going to